we solve equations, we look to use the order of operations in reverse. We are going to try to undo all of the normal operations that are around the variable for which we are solving. In the example you see here, there are two primary operations around the variable. The first operation around the variable is multiplication. The second operation around the variable is subtraction. Normally in the order of operations, multiplication would come before subtraction. However, when we're solving, we make sure we work in the opposite direction. So first, we're going to try to undo the subtraction, and then secondly, we'll try to undo the multiplication. If you're careful with the order of operations, many times the steps that are shared by operations can tell you what you need to use. So in this case, because I have a subtraction inside of this equation, and subtraction shares a step with addition, addition is what I'm going to use to try to solve. If I perform an operation to the left side of the equal sign, I must perform the same operation to the right. We want everything to remain in balance. That's the entire point of the equal sign. These two go away. The 7x comes down. Negative 9 plus 3 is negative 6. And then again, we still have this multiplication here, but multiplication's relationship is with division. Its inverse relationship is with division. So we just divide, and we're left with x is equal to negative 6/7. Resist the temptation to express this answer as a decimal, as many times the decimal answer will be less accurate. Your natural inclination will be to round, and then we will lose some of the value of the number, and then we won't have accuracy when it comes to using this number to perform other operations. It's best just to leave it as negative 6/7. In this second example, we actually have it written twice because we're going to approach this in two different ways. The easiest, more simplistic way to solve it would be to just distribute. Once the distribution is done, it looks just like the example that we already completed. We will add 27 over to the 81, and we have 36x is equal to 108. We divide by 36, and we get that x is equal to 3. That uses the order of operations in reverse. However, without the parentheses, However, if we really wanted to use the order of operations in reverse, we would notice that this x is tied up inside of this parentheses. Normal order of operations would say to deal with what's in here first, then deal with the 9 being on the outside of the parentheses. Because the 9 is on the outside of the parentheses, it would be the last operation we would perform. But because we're solving and we're trying to undo all of this, we actually could, if we're careful, handle that 9 first. What does that look like? Well, because that's a multiplication right here, I can divide this entire side by 9. If I perform that operation to the left, I have to perform it to the right. That 9 that was the divisor simplifies with the 9 from the numerator, and all I'm left with is 4x minus 3. Resist the temptation here to try to divide 4 by 9 or 3 by 9. The whole point of putting that 9 underneath is that it will knock out that 9 that's on the outside. That 9 that's on the outside is technically part of both the 4x and the 3. That's why it looks like this over here. So one division by 9 knocks out both the 9s that would have applied to the 4x and the 3, and then 81 divided by 9 is just 9. The advantage to doing it this way is that you end up with simpler numbers, smaller numbers, but you do end up in the same place. Now, this only worked for the very unique set of circumstances that we have here, where this 9 was the only number on the outside of the parentheses. In the event that there are multiple numbers outside of multiple parentheses, it would be more difficult to apply that skill. Take a look at this example. If I wanted to divide by 2, that would knock out this 2. If I wanted to divide by 4, it would knock out that 4, but I wouldn't be able to get both of them simultaneously. In this situation, it's actually a lot easier if we just distribute and solve as normal. The strategy in the last one worked out nicely because of just the one parentheses. Negative 6y combines with 20y to make 14y. 12 minus 8 is 4. And we get 92. 14y equals 88. Y is equal to 88 over 14, which simplifies to 44 over 7. Again, resist the temptation to change it into a decimal answer.